Hands up who knows what a webhook is. Oh, cool. And keep your hands up if you used webhooks before to implement some sort of integration. Cool, we've got a little cluster over here. Great. Today, before I go into that, I really have this weird obsession with webhooks. I don't know exactly what it is. There's just something that I really like, and I found them really powerful and really useful for creating an integration between something I'm building and other platform I'm integrating with. I can't really explain it, but I think it's just this passion that I have for connecting things together, and webhooks is a great way of doing that. We had an interview recently for a candidate, and for that half an hour of the interview, we talked about webhooks, which probably didn't go so well for her. She didn't take the job. Maybe she was scared off by my passion for webhooks, but either way, I really enjoyed just talking for half an hour about webhooks and what they can do and what she was building on her side that actually took advantage of what they can do. So today I'm going to give you an overview of what webhooks are, talk about what they can do, and then I'm going to talk a little bit about what we offer in terms of webhooks at MessageMedia. So there's a number of different things that we've built in that messaging and API space to allow developers who use our platform to more effectively integrate in a two-way fashion. So we've got a few different features of our webhooks that I want to talk you through. After that, I'm going to do a demo, and it's going to go very smoothly. I'm really excited about it. And then after that, I'm going to wrap up and just compare the different types of webhooks that we offer, what the features are and what the differences between them are, and give you some thoughts around how you could implement them in your systems if you haven't already. To kick off, so why webhooks? So webhooks to me are a really powerful integration mechanism between two systems. So we've got APIs where we can reach out and make a request to some system to get some data or to do something. And webhooks are kind of that same concept in reverse. So in an asynchronous system such as GitHub or Twitter or MessageMedia's messaging platform, when something happens asynchronously on that platform, we typically want to be notified about it so we can take some action on our side. So for an example, when a pull request is merged in GitHub, you may want to take an action on that, update some sort of status page or kick off a build within your platform. So rather than polling the GitHub API for checking that pull request list to make sure they've been closed, you'll just get a webhook sent to your platform that will tell you that this particular pull request has been merged, which can then invoke something on your side. Another example is on Twitter. So if you want to get a notification when your Twitter account is mentioned in a tweet by someone else, you can configure Twitter to send you a webhook with information about that tweet off to your platform, and then you can take action on that request that comes in, which will have information about that tweet and do something with it. So you might choose to publish it to a Slack channel where it can be responded to or followed up perhaps. And then finally, with MessageMedia's platform, a lot of the things we've been talking about today revolve around two-way conversations. So not just sending messages to customers, but actually receiving responses from customers, tracking those messages and if they've been opened or read or clicked on. And we use webhooks quite heavily to actually send that information back to the platforms that you're building that are integrating with our messaging API, so that then when those replies do come in, when those actions happen, your platform can take some sort of action in response to that reply or that status update or that change in some sort of messaging that happens asynchronously outside of your control. Igor mentioned this morning that, and I did a quick little look last night, our systems send around 5.5 million webhooks per day, which I was a little bit surprised at, but thinking back to it, it's not that surprising. But we do quite heavily use webhooks for typically status updates, so when a message changes status from submitted to delivered, or when a message fails to be delivered, and also when a customer replies to a message, which we call an MO, or a mobile originate message, which is when you send a customer a message, hey, your haircut's tomorrow, can you confirm that you'll be coming, or reply no to cancel. If they text in yes, that gets pushed back to your platform via a webhook, and then again you can take action on that. And we'll talk through an example of what that looks like. So for me, webhooks are just an API in reverse. So rather than writing some code to integrate and consume an API, you're building an API which is going to catch those webhooks and then do something with that data. So it's a very similar concept. As an example up on the screen there, hopefully that's legible, this is a webhook for a delivery receipt that's come in. So a customer has sent a message out from our platform and they've sent it to the phone number ending in 156 up on the screen. And our system has processed that message, and then we've delivered it or submitted it to a provider, which has then delivered it to a handset. And you can see on the 1, 2, 3, 4, 5th line there's a status field, and that status field has a value of delivered. So what this delivery receipt is saying is that you've sent a message to that phone number, and that at that point in time, so the date received just above it, is the actual time down to the millisecond when that message was received on the handset. So then you might want to take some sort of action based on the delivery receipt happening. So the message was delivered, great, let's update some status in our database to say that Adam has been sent that message. Or if it was a failed message, you might choose to take some action to perhaps send them an email or some other form of communication instead. So these webhooks really allow you to take actions when something happens inside the MessageMedia platform. And this is just an example of one of the ways that you could do that. So now I'm going to talk through a scenario with a little bit more detail around how this works, just to really solidify that concept in our heads. So on the left, we've got Dr. Smith, and she runs a doctor's surgery, and she uses a patient management system to manage her patients. So all of her appointments are coming in, cancellations, bookings, scheduling, all that kind of stuff. That patient management system has an integration with our messaging API, and what that allows the patient management system to do is send appointment reminders out to all the clients or customers, patients probably, best word, the day before their appointment. So we can see here that I've received a message confirming my appointment with Dr. Smith tomorrow at 9:30 a.m. And then I've been prompted to reply yes to that message or no to cancel the request. And again, we saw with RCS that that's become much richer and much nicer. But at the moment, for this example, we're just sticking with SMS. And in this case, we're asking the patient, which is me, to reply yes or no to that message. So that message gets sent to my phone as an appointment reminder. And then I reply yes to that message. So I've received that from a phone number. I've replied yes to say yes, I'll make that appointment tomorrow. So that message goes back into the MessageMedia platform. And then because Dr. Smith has configured her account to have webhooks enabled, we will push a request back to pms.doctor.com, it's a mouthful, to the URL/reply. And that webhook will contain details around the phone number, a timestamp of when that message was sent by myself, and then also the content that I replied with. So you can see that I replied with yes and an exclamation mark, and that's exactly what was included in the webhook that was pushed back to the patient management system, which was configured as a webhook by Dr. Smith on the MessageMedia API. Sorry, wrong way. One thing with that though is there's an issue with authentication there. So that URL that we're pushing the webhook to, so pms.doctor.com/reply on port 443, there's nothing to stop anyone from hitting that endpoint and sending a message to that with the same body of the request to sort of potentially manipulate that patient management system and change things in that calendar. So that's one important consideration to think about when you're actually creating that API that receives webhooks on your side. How are you going to authenticate and protect any malicious requests coming in if someone wants to find out what that webhook handling API that you've built is? So we can see here that we've got Dr. Evil now, and he's potentially attacking the patient management system by sending it requests to that webhook handler with a no response rather than a yes response. And in a fairly benign example here, we're seeing that all these appointments are now getting cancelled because Dr. Evil is sending all these requests to Dr. Smith's system with the text in it no. And Dr. Smith might be looking for the word yes or no, and if it's a no, she'll be cancelling those appointments, therefore not making any money that day. So fairly benign example there. But if we extend that concept a little bit and talk about where webhooks are being used within, say, a financial transaction management system, where webhooks are being pushed to this transaction management system and they are affecting transaction of money between different accounts. We can see here that Dr. Evil, again, if there's no authentication on that webhook catching script or that URL that they're pushing the data to, Dr. Evil can then just send requests to that endpoint to effectively change parts of that transaction management system when he's not supposed to. So I'm going to talk through a few different ways that you can implement authentication in your webhooks, starting at the sort of the basic and quite insecure through to the best that we can come up with at the moment. So to start with, the most simple way is to actually look at the IP address that that webhook is originating from and filter based on that. So the webhooks will be coming from some sort of web server out in the big, scary internet, and your provider who's sending those webhooks to you will typically be able to tell you the range of, or a set of IP addresses that those webhooks are coming from. You can then, in your webhook application, or the application that's receiving the webhooks, filter the IP address that those requests are coming from, and if it's not coming from an address that you know and trust, then you can reject that webhook and say that I'm not going to process this any further. So in the patient management system example, you might just reject that request and not actually update the patient's confirmed or cancelled status. Fairly simple. It is a bit of a pain when it comes around to having customers or providers where the IP address range changes. So if they're hosting it in some sort of cloud platform, the IP address range, if they haven't fixed it to a specific set, might come from anywhere in that provider's range. So it's pretty hard to lock it down to a specific IP address, and if that changes, your webhooks will stop working. So it's a nice solution, but it's not great. It's got its caveats about it. Another way to make it a little bit more secure is to include some sort of shared secret between your application and the provider that's sending the webhooks to you. So we saw before that a webhook is basically just an API request to your platform. And you could potentially add some sort of shared secret to the configuration of the webhook on the provider side that your application knows and trusts. So when you do receive webhooks from that provider, you can check for that shared secret and make sure it's present. If it's there, great, let the webhook through and process it and do whatever happens on your side. But if it's not present, then you can safely assume that the person who's sending those requests doesn't have that shared secret and is therefore trying to do something malicious to your system. So when you configure the webhook with the provider, you put that shared secret perhaps as a query parameter in the string. So when you're configuring that provider to say push to pms.patientmanagementsystem.com or whatever your webhook URL is, you can include some sort of shared secret in that string or perhaps in the body so that when that provider sends a request, that'll be included. You check for that and it's all good. If it's not there, obviously it's not coming from the place that you'd expect and you can reject that request. So that's pretty good. Does the job. It does require you to be able to configure parameters or query parameters or perhaps post-body parameters on the provider side. If you can't do that, you can't really implement this. A similar, probably better way as well is to actually, if you can configure the headers that get sent from the provider to your system, you can configure the headers to perhaps include an authorization string, which just gives you nice, simple, basic authentication out of the box. Again, that depends on the provider being able to actually allow you to configure the headers of the request that gets sent to your platform. But if they do, great, chuck that authorization header in and check that the request has that authorization header when you receive it, check the username and password match, and you're all good. If it doesn't, again, reject the request and it's not coming from a reputable source or the source that you expect it's coming from. The third and most secure way of doing this would be to actually attach a signature to the request that gets sent across the wire, and then your application needs to verify that that signature is correct. Now, there's a number of different ways to do that. You could do sort of a HMAC type signature and attach that as a header to the request. But again, all of this depends on the provider implementing that for you. If they don't, there's nothing really you can do to attach a signature. It's up to the provider to have that functionality for you to actually consume. But in this example here up on the screen, we can see that the body, or the headers of that request, contain an authorization header, and that header contains this signature string. And in the pseudocode I've got just below it, that signature is made up by taking the date of the request. In the header, we can see just above the authorization header, it takes the request line, and it also takes in a shared secret. So you still have a shared secret between the two platforms, and that's used to then encrypt that signature. And what that does is that helps to prevent not only someone sending a request from an illegitimate source, but it also prevents replay attacks. So because we have the date as part of the signature, if someone was to take that request and try to replay it later on, and your application is checking the date is the correct time within a few seconds, then you can safely say that if someone sends that request and the date times do not match, then that's a replay attack and they're trying to actually take that same request and send it to you again. So you should definitely reject requests in that state. And this signature allows you to actually implement that. There's also the request line included as part of the signature. So That also means that if someone was to do a man-in-the-middle attack and try to take this request, modify it, and send it on through to your system, that won't work either, because anytime they modify the request, that means the signatures won't match anymore. And when I might say the signatures won't match, in your application, you'll need to follow that same logic or that same algorithm, create your own signature, and make sure the signature that you've produced matches the signature that was sent. So you're basically comparing that the two signatures match, the one that was produced by the provider and the one that was produced by yourself. Make sure the signatures match, and if they do, great, the request is timely, it's sent by the right person, because there's a shared secret in there as well, and it hasn't been tampered with. If the signatures don't match, one of those criteria hasn't been met, and there's potentially something a bit amiss going on, and you're safe to reject that request and not let it go through to your system. So there's are three different sort of levels, simplified levels of security that you can apply to authenticating webhooks that come into your system, all with varying degrees of complexity, but also varying and increasing degrees of security as well. So now that we're secure, so what are some other considerations that we sort of think about when we're implementing webhooks? And the biggest one for me, which I've spoken to quite a few customers about, is scalability and spikes in traffic. So if we go back to the patient management example, let's imagine Dr. Smith doesn't have one practice, but she has hundreds or thousands across the country. And at 9 a.m. every day, every practice management system sends requests or sends reminders out to all of the patients that day. So that's scaled out from perhaps 10 messages out to hundreds or tens or millions of messages at 9 a.m. that morning. And if everyone's checking their phones and replying to those messages with a yes or no pretty quickly, that means it's going to be a whole flood of webhooks coming back to that patient management system, which need to be processed. And if they're not being processed in a timely fashion, that can lead to back pressure on that webhook provider. And then it's kind of anyone's guess as to what's going to happen if there's timeouts, but the message still gets processed and that message gets sent through again. What happens in that situation, for example? So a pattern that I really like to encourage people to use when implementing a webhook catching system is to actually split up the receiving logic and the business logic into two separate parts and join them with some sort of asynchronous connection like a queue. So your receiving logic is literally just as simple as possible. So take the webhook, validate it, authenticate it, make sure it's valid, and drop that message onto a queue. That should be really simple, fast, efficient, static code that's just checking the webhook's correct, drops it onto a queue, and then you've got another part of your system which is actually implementing the business logic. So this might be the part that's taking that request, looking at the data and updating something in your database and doing some further actions downstream in your system. And those downstream actions might be a little bit slow. If your database hasn't scaled up to handle all those requests coming in at once, that might start to slow down and put back pressure on your system. So having that asynchronous queue in the middle there allows you to absorb that back pressure. So all the messages come back in, all those webhooks come into your system, and then you've just got a big queue of requests that you need to process, and you can process them in any fashion that you want, really. If you want to slow it down, just put less computing power on that business logic part, and those requests will just sit in that queue until you're available to process them in a timely fashion. So that's the first part, and that's pretty easy to implement. If you're using Amazon or Google Cloud or any of those provider platforms, they'll provide really simple, easy-to-use queuing platforms. So Amazon's got SQS, I'm sure Google has one as well, where you can literally just drop some items into a queue and then pull them off the queue in an asynchronous fashion at your will. So that's a nice, easy one to implement, and it's kind of nice to put that in at the start rather than trying to put that in later on, because breaking that up is a bit difficult, especially when you've got live webhook traffic coming through your system. How do you do that? So if you're starting out, start with this pattern straight away and you'll save yourselves a lot of trouble later on. Another good practice is, again, it's an API. So the responses that you send back are going to be interpreted some way by the provider who's sending those webhooks to you. So just like you'd expect an API to respond appropriately with 200s or 400s or 500s, you should be appropriately responding to that webhook provider with 200s or 400s or 500s if you can. So if you manage to process that webhook correctly, send them back at 200 to know that that webhook was processed by your side correctly. If it was invalid, send back a 400. And if there's a problem on your side for whatever reason and you want them to retry that webhook, send back a 500. Now, I'm not saying that all the providers will implement status code handling on their side, but typically they should, if they're good. and they will, if there's a 200 response, they'll say the webhook's been received by the customer and we're happy to just finish with that one. If it's a 400, their system might perhaps put that off into some sort of notification queue and send you an email or get in touch with you because that webhook that's trying to be pushed is invalid. And if you send back a 500 or there's a timeout, they may replay that webhook later on because there's some sort of temporal problem with your system, and they'll retry that webhook later on for you to actually process when everything's up and running again. So be a good citizen and respond appropriately to the webhook that's been pushed to your system. Last point, or the last good practice, I feel, in catching webhooks is try to make them idempotent. So things will go wrong. There will be network connection issues between the provider and your system. Your system might go down or might not respond correctly. And that webhook might get retried again and again and again. So if you can, make sure that when that webhook gets sent to you and some sort of action takes place in your system, if that webhook is again pushed to your system, it behaves in the correct way. So it takes some sort of idempotent action where it's not perhaps recreating a second deployment for that customer if that webhook was accidentally pushed to your system twice. So perhaps check the webhook ID, check some sort of, create a hash of the request, and if that request has been received, you can ignore it again. But just make sure that you understand that things will go wrong. It is the internet, and have some application logic that will deal with that nicely. Because there's nothing worse than trying to debug a whole lot of webhooks that have come in. You don't know what the request was. Something's happened in your system and you can't quite work out why. So make sure that you're just dealing with that nice and gracefully. So to recap on that webhooks overview, make sure that you're using authentication. I'm sure Ben would agree with me on that one. But make sure that you're at least checking the IP address where they're coming from, if that's all that you have available. But potentially include some sort of shared secret between yourself and the application provider or the webhook provider. And if you can, have some sort of cryptographic signature, which just gives you that extra layer of security. That will help to protect your webhooks and your implementation. Next, build with scale in mind. So if you're starting from scratch, have that separation between your receiving logic and your business logic with some sort of queue in between to help deal with that scale that should inevitably come with your platform. Follow good conventions, so respond appropriately to the request, and then be prepared for things to fail. So if you can, build idempotency into your webhook handling logic to make sure that the same request coming through twice won't break your system or cause some sort of heartache in your database. So that's the overview. Now I'm going to talk through the three different parts of what I like to call the webhook ecosystem that we have, and what they do, how you can use them, and then after this overview I'll do a demo where we show all of those things working. So to start with, we have three parts of that ecosystem I want to talk about. The first one is our pre-configured webhooks via the messaging API. So this is kind of the simple, easy use case where when you send a request, actually I'll go into more detail, but it's a nice easy one where you can just include the webhook with each send message request and we'll push delivery reports and replies to that webhook. The second one, which is kind of cool and exciting, I'm really excited that it's out in the public now and everyone can use it, is the ability to configure custom webhooks at an account level. And we'll go into more detail on that in a sec. And then finally, there's the signed webhooks. So as before, I was talking about signing webhooks and making sure they've been signed and have some sort of cryptographic signature on them. We have a service that you can enable on your account, which will sign every webhook request, and then it's up to you in your application logic to actually check that or verify that signature, so that you know that A, it's not a replay attack, B, it's not a man-in-the-middle attack, and C, it's actually coming from MessageMedia and not someone else. So we'll start with the pre-configured per message webhook, and this is really nice and simple. So on the left, we've got a request to the Messages API where we're sending a message that says hello world to that phone number ending in 156. And in green, I've highlighted a property or a parameter that we've included in that request called callback URL. So in that request, in that parameter, you put the value of the URL that you want webhooks to be pushed back to. And then on the right, we can see that whenever any delivery reports are received for that message, those delivery reports will get pushed back to the server that you specified. So we can see I've got webhookcatcher.com, and this webhook has then been pushed to webhookcatcher.com with similar details to what we saw in the first example. So we can see that the status of that message was delivered, and it was delivered to that phone number. Similarly, if you do that same request and someone replies to that message, you can see on the right that we've also received a webhook which contains the reply to that message. So if we have a look here, we can see that the content of the reply message that was sent in response to the message that I sent via the API was hello back. So that webhook has again been pushed to that webhookcatcher.com URL. And when I say it's pre-configured, what I mean is that this structure, it's a post request, it contains a JSON body, and that's pretty much it, is all pre-configured. That comes sort of as a canned response for both delivery reports and replies. You can't change that or modify that at all. And then there might be people in the crowd that say, I don't like JSON. Is there anyone who prefers XML over JSON? Cool, just killed the next part of my presentation. We do now allow you to configure all the parameters that come or that make up a webhook. So you obviously can control the webhook, the URL where the webhook is pushed to. You can change the method that gets used for pushing that webhook. So it can be a GET request, a post, patch, put, or a delete if you want to use a delete for whatever reason. You can change the encoding from JSON to XML to a form encoded. And you can also specify your own headers with that request as well. So you can set your own headers, like the authorization header I mentioned before. You can set that using the custom webhooks API. You can also actually control which events this webhook fires on. So there's a number of different events that happen: delivery receipt received, delivery receipt with various statuses, an MMS message was received, a normal SMS message was received. You can control each event or each webhook to fire on different events. So you can actually different webhooks for different events, sending different data to different parts of your system in different formats. You can also control the body of the request. So before we had a fixed JSON structure, you can change that to be whatever you want using this templating engine that we've got. And if you don't want to use a request body, you can always include the parameters in the request header as query parameters. So let's have a look at a few examples of what that looks like. So on the left, we can see the template, I guess, and on the right, we've got what that actually produces. So we can see that it's the same request. It's a post request going to webhookcatcher.com. I've added my own custom header, so MessageMedia-type, and I'm saying this is a reply message. But we can see that I've changed the structure of that JSON document that gets sent to me in the webhook to be a little bit more structured. So I've got a content object and an address object, so I've just changed around the parameters. And we can see in the green that I've got these templated fields, which correspond to the data that comes from the webhook. So before I showed that we had a webhook that says hello back, because that's what I texted in as the reply. That gets actually populated in this MO or $MO content field. So there's a whole lot more parameters that are listed on the developer portal in our documentation section. But you can see sort of how powerful this can be for you to construct your own bodies for your requests or even query parameters to structure that webhook to be how your system wants to consume it. So if you've already got some sort of webhook catching logic, you can actually construct or customize the webhook to match that logic you've already got. And on the right, we see that webhook actually being sent, and that's what the templated parameters have replaced with values in that webhook. Now we jump to an XML example. So again, this is exactly the same thing, exactly the same structure, but here I've represented it in XML. So on the left, we've got that XML template, and then that, when a webhook gets actually sent, it resolves to what you see on the right-hand side, where all those templated parameters are replaced with values for that individual webhook. Again, we've also used the custom headers as well, so we've added our own header to that request. And then finally, we have the GET request. So if you don't want a request body in your webhook coming through for whatever reason, you can just use query parameters instead. So we can see here that we've just used that same, I've just put it horizontally instead of vertically, but we're using those same templated parameters in the query string, and they then get repopulated. They'll be HTML URL encoded, obviously, when we send them. But you can see that those templated parameters just get replaced. So essentially, in this request, you can build up your own request, put these templated parameters in, and then every time we send a webhook to you, they'll get populated with the fields for that specific webhook, which I think is quite powerful. It allows you to control what's getting sent to you and also the format, so that then you can decide how you're going to implement on your side, rather than having to follow that predefined logic of that JSON document that we send for the per message webhooks. I call it per message and per account. So for the per message example back here, you can change the URL for every message that you send, and that URL is what's used to push back events for that specific message. For the custom webhooks that we have here, they're at an account level. So you configure that at your MessageMedia account level, and then all messages received on that account or sent on that account will have those webhooks invoked. So there's a little bit of a difference there, but typically you'll set up your webhooks once and you'll leave them set that way for your account, unless you're changing your logic every time, but that doesn't quite make sense. Cool, and then jump onto the security part of it. So how do you make it secure? And before I mentioned that we have a service that allows you to sign requests, or we sign the requests, and allowing you to verify the signature and make sure the webhook is not a replay, it's not a man-in-the-middle attack, and it's actually coming from the place that you expect it to come from, which is us. So to do that, we include a signature if the Enterprise Webhooks feature is enabled on your account, which it has been for all of the DevDay accounts today, so you'll actually be able to have a play with this very shortly. In this request, which is the same one as the one I showed on the start of the slides, there is 5 new headers that have been added to it. And I've highlighted them in green. So the first one is the key ID, which represents the signing key that we use to sign that request for you. More details on that later. There's the cipher type that we used in that signature, and also the digest type that we used. So they're configurable, and you can control those based on what you want to consume on your side, but using the default is pretty safe. There's also the signature itself. So we can see that big long string that's broken over many lines. That's actually the signature that we created on our side that you then need to verify on your side. And then finally, we also include a date header as well. So that date header allows us to make sure that this request was received or sent at this time, and then you can check on your side that if it was received at that time plus or minus 5 seconds, then it's safe. But if it's been received outside the time in the header, you can probably assume it's a replay attack and someone's actually copied that and tried to send it later on. So how does that kind of work as a diagram? So very simply, we take the request line, the date, and the body of the request, if there is one. In GET request, there won't be a body. We then, using a private key, so we actually let you generate a public-private key pair, and we keep the private key and give you the public key. So with that private key, we'll sign that request. And then using the public key, when you receive that request, you can verify that signature. If the signature is verified, then you know the webhook came from MessageMedia, you know the webhook hasn't been tampered with, and you know that it has come at the right time. And if it hasn't, then you can reject that request because there's something wrong with it and you shouldn't be processing it through your system. Any questions on all of that so far, before I dive into demo time? Yeah?
Is there any kind of same origin policy for the callback URLs?
We don't have that configured yet, but it's something I've wanted to add in. If there's enough requests for it, I'm sure Casey would bump it up his list, but not quite yet, no. Cool. So now I'm going to do a demonstration, and I've put all the details of this demo, like step by step, up on GitHub. So if you want to follow along on your laptop, you can, or you can sit back and watch me do it. But that's all available in a repository called Webhooks Demo on our MessageMedia GitHub account. There's a few steps involved, and it's got a lot of moving parts, but this is going to be fun. So, anyone used ngrok before? Nope. Cool. So ngrok's a really cool tool that if I want to have requests go to my local machine, I can't exactly go and configure localhost in my webhook provider to send those through to this machine. But what ngrok does, it gives me a public URL, which then gets tunneled through to this machine here. So I can actually configure that ngrok URL to forward requests through this machine and actually show what's happening on the screen. So I've already set up my ngrok tunnel. And what I've also done is checked out that repository that I had on GitHub. And the first thing we need to do is actually configure it. So there's a configuration.php file. And in that, I've got my API key, my secret, which is the phone that I'm going to use to send messages from. And I'll just check that the phone number's the same. So I've got Alice up here for doing the demo. And then I've also got my ngrok URL, which is that public URL, which will forward all the requests through to this machine. So that's all set up. I did that beforehand. And the first part of this demo is it's literally going to walk you through all of those different types of webhooks that I talked about before. So the first part of it is actually just showing that predefined webhook example. One last thing on ngrok as well. So that allows that tunnel that's forwarding all these requests to this laptop. It allows me to inspect those requests as they come through. So that allows me to show you the webhooks as they come into this machine, which is really cool. So let's have a look at the first file here. And the first one is predefined webhook.php. This one here is literally just sending a message to the phone number that we've got configured to my machine with the callback URL configured to this machine. So any delivery reports that come in or any replies that come in will actually get forwarded to this machine as a webhook. So what I'll do is I'll jump over here and I'll actually get rid of that. You can all see up on the screen, all right, size is good. Bigger. Just bump it up a little bit. All right. So what I'm going to do is run PHP predefined webhook. And we can kind of see that sent a message through the phone, which is awesome. And we can see here the callback URL that was specified, sorry it's a bit stretched, was this laptop here going through that ngrok URL we set up. Now if we jump over here, we can see the webhooks have actually come through and been forwarded to this machine. So let's have a quick look at those. And as the slides and the explanation before, this is that predefined JSON document that we had earlier. So we can see that we've received a delivery receipt for that send message. So I've sent a message and now MessageMedia is pinging me back saying that message is en route, as we can see in the status there. And then we can also go to the next one and see the message was submitted. So we've received 2 status updates for that single message I just sent there so that I can track the progress of that message. And it's kind of as simple as that. So I've sent a request through, jump back here, sent a request through, and I've said in that request, please forward all webhooks back to this URL here. And that's just worked nice and easily for me. So that's cool. I'm going to move on to the next part of the demo now, which is, I'll clear this, which is looking at configuring my own custom webhook using the Webhooks API. So I didn't mention earlier, but to configure your own custom webhooks, we've actually got a Webhooks API to configure your webhooks so that when you send messages, we'll send them to those configured webhooks. Follow? Cool. There's documentation on the dev portal. We've got an SDK as well. And I'm going to use that SDK in this example here. So what I'm first going to do is open up this file. And this file is using the Webhooks SDK to configure a webhook in the structure that I showed in the slides. So we can see here that I'm creating a new webhook. And that webhook is a post request JSON. It's got my own custom header that says hello world. And the template is just what we saw in the slides. So what I'll do is I'll jump over here and I've got a little script that's going to clear any existing webhooks for me, just so we can start from a clean slate. Yes. Cool. And then I'm going to run that create JSON webhook. Not that one. Create that one. So that should send a request off to the Webhooks API, and that's configured a webhook on my account in the structure that I've asked for, so that when I send a message to the phone and I reply to it, I'm now going to receive webhooks in that format rather than the predefined format from earlier. So let's give that a go. And to do that, I'm going to send a message to the phone. So I've got a simple script that sends messages without specifying the callback URL because I'm doing it at an account level. I've got that message. Oops. And then I'll reply to that. And we should see a webhook come back. Let's bring that up. In here, that will show that reply message coming in the structure that we defined. So, yes. Send a message. And then we've seen that webhook come through, and we can see that the JSON body is now different. It's following that structure that I asked for, not the one that I was told to use. And we can also see that it's included that custom header that I set as well. So I've got that custom hello world header, which is now going to get included with all the webhooks that get pushed to the system. So that's the JSON example. Hopefully, is that all readable up there as well on that screen? You can see that okay? Cool. Next one we're going to do is we're going to clear that webhook now, and we're going to go with the XML example just to show you how that one works. And again, it's a simple script that is calling our Webhooks API. And this time it's just saying, create me a webhook with that template and fill in these fields with the appropriate values when you send that webhook to me. So I'll jump up in here and I'll run this script, create XML webhook, run that, creates a new webhook for me. So the old one's been deleted, I've created a new one now, and then we're going to follow the same process. So let's go PHP send message, message goes to the phone, and then if we go back to here, and if we clear this, if I reply to that new message that's come through, there's hello, you see that reply come back in as a webhook, except this time it's formatted as XML rather than JSON. So again, I've controlled the way the webhook's been pushed to me. We've also set that custom header again here. So I've got that custom header as part of that configuration as well, which is kind of cool. The last one I'll demo, which again follows the slides, is we'll configure ourselves with a webhook that comes through as a GET request with the details in the query parameters rather than in the body. So again, nice and simple, let's just clear out that existing webhook we created. And then if we have a look at the code for this third one, create get webhook. So a bit simpler here. We're still setting our own custom header, but you can see that rather than setting a body in the request, we're just saying in the URL, which is body-URL, use the ngrok URL, and then put a whole lot of query parameters on the end, and the value of those query parameters are those $ templated variables that we've seen before. So we will create that webhook in our system now. Create get webhook. Awesome. Make that one a bit bigger as well. So we've created that, and then we go PHP send message. Again, it's going to send a message to this phone. Message has come through. Reply yes. And if we go over here, we can see that webhook has come through. And rather than being a post request, it's now a get request. And we can see that these values here are included as query parameters, and there's no body in that request. They're just being passed along in the URL. You'll note that destination address is not populated in this example. That's because I'm using a rotary number rather than a dedicated number. So that doesn't actually show up here. That's not a bug, it's meant to be like that. But you have logic on your side perhaps that would handle that situation. Or if you are always using rotary numbers, you might choose to not include the destination address of that reply because you're never going to know what the destination is. A little complexity with rotaries, but it all works as expected. So I'll clear that one out, and then we'll get to the last part of the demo, which is looking at the secure webhooks. So this one here is a little bit more complicated. The first step is that we need to create that signing key pair that I talked about earlier. So we have a signature key API where you can create and manage signature keys. And when you create one, MessageMedia will keep the private part of that key on our server, and you will be given the public key. And then using that public key, you can verify anything that's been signed using that private key. So the first part of this is to actually create that signing key using the Signature Keys API. Again, documentation online, nice and easy to use. Just create a post request to the endpoint. It will return the public key. So let's do that now. PHP. First, I'm going to clear any signature keys that I have, just to make sure I don't have any conflicts. Clear signature keys. Yes. Got a few. Cool. So then we will run create signature key, and before I run it, I'll just show you what the code looks like for that. And we've got this one here. So before in the slide, I showed you that request which had the headers in it. So it had the digest, it had the cipher, it had the key ID. We can see here, when I create a key, I can choose the cipher and the digest that I want to use for that key. And they're the same values that get returned in the headers in that webhook. So I've specified them in this request, and that's going to create a public key for me. This is going to save it in a file called signingkey.pem with the key start and end around it. And then it's going to enable that key as well. So you can have multiple keys on your account, and you need to select one that's enabled, which will be used for signing requests. The others will not be enabled. And what you can do with that is implement some sort of key rotation policy where you create a whole lot of keys, or you want to rotate your keys every month, create a new key, get it all set up, and then just switch it by disabling the old one and enabling the new one. So it allows you to do a nice seamless switchover of your keys if you have a rotation policy that you need to implement. I'm not going to do that here. We're just going to enable the first key we create, save it to a folder on this machine so we can use it in the validation step, which is next. So let's run that one now. Create the signature key. We can see the response has created the key for me. It's given me an ID. The cipher and the digest are set correctly. And we can see the public key returning the response as well. We've taken that and saved it to the machine. Got a key created, it's been enabled, all good. So next up is to actually send a message to the phone and inspect the response, and we'll see those signatures in the webhook that comes through. But first, I'm going to create a new webhook to actually make that happen. So I'll clear all my existing webhooks again, and then I'm going to create a new one, which I've got. Just create JSON SIG webhook. This one's pretty much the same as the JSON one earlier, except it's going to a different URL. That URL is pushing to a specific script that I've created, which is going to be used to implement the verification logic, which I'll show you in a second. So I'll create that. So again, it's created the template for me, and you can see at the top there that it's going to, rather than going to index.php as we had earlier, it's now going to signed webhook handler.php, which I'll show you in a second. But before we look at that, let's quickly send a message to the phone, and we should see a webhook come through, and we can look at the headers and see that signature actually being set, hopefully. So PHP send message, another message to the phone, message came through. Let's reply to that. So we sent a reply to that one, and the webhook should come through. You see it's come through, and then if we jump into the headers section, we can now see that we've got those headers set up as I showed in the slides earlier. So there's the cipher type, which is RSA, which is what we set up in the signature key when we created it. There's the digest type, again, created that with the key ID. So if we scrolled up in that output, we'd see the key that was created has that ID, so we can make sure that we're checking the right key. And then the signature as well, which goes a long way that way, but that's essentially the signature that we need to verify now on our side. Now, before I show you that, I'll quickly open up this verification signed webhook handler. So this bit of code here is essentially the code that you'll need to implement in your application, which will take the webhook, check the signature, make sure it's verified, and then actually action the webhook. So this will be in that diagram I had earlier where you split up your receiving logic and your business logic. This is part of the receiving logic. This validates the webhook's all good, and then would chuck it onto a queue. Now what I've done here, if anyone can read PHP, is if it's verified, I'm going to respond back with verification successful and a 200 HTTP response code, because we're good HTTP citizens. I'm also going to save the data of that request into a folder called good requests with just some unique ID on it. If the verification failed for whatever reason, I'm going to respond back with verification failed as the response. I'm going to save it into a folder called bad requests. And then I'm going to respond back with a 401 HTTP response because that response or the request was unauthenticated or unauthorized. So we should see, if we go back to this ngrok example, if we scroll down, we can see that that webhook went through that script and responded with verification successful, which is really cool. We can also see that we've got the 200 OK response returned. And hopefully, if we pop back into the folder where this code's running, we've got a new folder called good requests. And inside that, we can see that the request data was saved into this file. So rather than saving it to disk, you might want to save it to a queue or do something else with it. But what this is showing is that we received this request with a signature on it. Our code that handles signatures checked the signature was valid, verified it, and said, yes, I'm willing to accept this request. Now, what happens if someone else tries to hit this endpoint without a signature or with an invalid signature or with the wrong date or has tampered with the request, which means the signatures won't match? So let's quickly do that now. So I've set up a postman request there. Hopefully you can all see that. And essentially it's going to the same URL that I've got configured as my webhook handler. So that ngrok URL plus the signed webhook handler script. The body's the same. It's going to include a content application JSON content type. So it looks like a normal request that should be received by application. However, with this, I haven't included the signature and I haven't included the date string. I haven't included those extra headers that MessageMedia includes. So with a bit of luck, this one will get received by that script that we had, and it will fall into that verification failed section. So we can assume that that's a bad request and we shouldn't be processing it any further or letting it into our system. So let's give that a go and see what happens. Verification failed. Awesome. So it's checked the signature didn't match. In this case, there was no signature to match with. But in any case, if the signature was wrong, or if the timestamp was wrong, or the content was different, then we'd see that same result as well. We can also see in really tiny font just there, the 401 unauthorized, which is the response that our script was returning back. And if we jump into the folder that we had, we've now got a folder called bad requests, and we can see that that request has been put into that bad folder. And you might choose to do that in production as well and capture all those bad requests and see where they're coming from and try and track down if someone is actually trying to hack you or if there's something actually wrong with your verification code as well. So a nice simple pattern that you can use, and you can implement this in any language, of webhook comes in, verify it, validate it, make sure it's all good and trusted, and then put it somewhere to be then processed asynchronously later on. All of this code is up on that GitHub repository, as well as with a nice thorough README file, so you can actually follow this one along at home and have a play around with the webhooks and actually do this yourself. Enterprise Webhooks has been enabled on all of your accounts. However, it's a paid feature, so once you've played with it, we're going to charge you money for it. Custom webhooks is free to use, so anyone can go to the custom webhooks API and set up your own webhooks. And obviously the callback URL predefined webhooks is free to use as well. So let's wrap all that up and jump back into my slides. So just to summarize sort of what I've walked through with all of that. In terms of pure webhooks, we've got sort of two styles or two flavors. The first one is that pre-configured per message webhooks. So if you want it to be nice and simple and just want to send off a request and get something received to a webhook URL, set the URL in the webhook in the send message request. But if you want something a little more powerful, a little more controlled, and you actually control what data is coming back, you can use those custom account level webhooks. And you can see sort of the differences up on the screen there. But the main thing is that one is configurable, and you can change it to match whatever you want, and one isn't. It's predefined and comes as is. For the second part, so for security type conscious people in the crowd, we've got the different verification methods that you can use to authenticate webhooks coming into your system. So no verification means that you can't really validate who actually sent the request to you. You can't do that replay attack protection with the date header, and you can't do the request tampering, so someone could actually sniff that request, replay it onto you and change the contents of it. You can't really control any of that. With the IP address filtering and the shared secret, you do have some control. I'll put a question mark there because it's not perfect. But you do have some control over checking where the request came from. For example, they might spoof the IP address, so that kind of bypasses that. But you don't have that replay attack protection and you don't have the request tampering. However, with the shared secret and with the custom webhooks that we have, you can put a whole lot of headers in there and validate those to implement some level of security, which is obviously better than nothing. And then at the right-hand side, we've got Enterprise Webhooks, which allows you to verify that the request came from us because we're the only ones with that private key. So when you validate it with your public key, you know it's us. There's the replay attack protection, so that date header isn't included and is made up as part of the signature. So if the date is slipping, then that'll get detected by the signature verification. And there's also the request tampering. So again, the request is included in that signature. So if someone takes that request, changes it, and forwards it on to you, the signatures won't match anymore when you're trying to compare them. So that is all I have on webhooks. Any questions? I've got a few minutes left. Silence. I've covered everything. Awesome. Good stuff. Please have a look at that GitHub example. Again, your accounts are all set up, so play around with it, see how it works. And there's all those SDKs as well that allow you to interact with the different APIs that you need. So the messaging API for sending, the webhooks API for controlling your custom webhooks, and the signature key API for managing your signature keys. Thank you.